Hello friends, in this video I'd like to solve the following problem from the Moldovan Mathematical Olympiad for 11th graders 1998, problem number 6. We wish to find all functions f from the set of rational numbers into the set of real numbers which satisfy two conditions. First, f of minus 8 is 0, and second, f of x plus y equals f of x plus f of y plus 3 times xy times x plus y plus 6 minus 8 for all rational numbers x and y. So it's a nice problem. Here are my hints. First, the basic idea behind my reasoning is to reduce this problem to Cauchy functional equation. And to do that, you should try to express this expression in terms of x squared, y squared, x plus y squared, x cubed, y cubed, and x plus y cubed. And to do that, you should use these two well-known formulae. And then you should make a suitable substitution to reduce our problem to Cauchy functional equation. And also keep in mind this very useful fact, fundamental fact, that if a function g is defined over rational numbers, and if it satisfies Cauchy functional equation, then, so g of x plus y equals g of x plus g of y, then our function must be linear. So g of x equals ax for some real number a. So give this problem a try, and I will see you in just a minute. Oh, all right. So as I suggested, let's start with this part. 3xy x plus y plus 6, and let's write it in the following way. It's 3, so it can be written in the following way. It's 3x squared y plus 3xy squared plus 2 times or 9 times 2xy. And now I will do the following trick. I will write x squared, or x cubed rather, x cubed plus 3x squared y plus 3xy squared plus y cubed. I will also write plus x squared, or 9x squared, plus 9 times 2xy plus 9 times y squared. But now I have introduced x cubed, y cubed, 9x squared, and 9xy, 9y squared. So I have to subtract x cubed, y cubed, 9x squared, and 9y squared to balance this expression. And after doing that, let's take a look. This entire blue expression, it's just x plus y cubed. Then we have minus x cubed minus y cubed. And the entire pink expression, it's 9 times x plus y squared minus 9x squared minus 9y squared. Very well. And now let's finally consider our very first functional equation. It is that. And now we have demonstrated that it can be written, the right hand side can be written in the following way: x plus y cubed minus x cubed minus y cubed plus 9x plus y squared minus 9x squared minus 9y squared and finally minus 8. And now I will do some shuffling. On the left hand side I have f of x plus y. I will put x plus y cubed on the left hand side. I will also put 9 9x plus y squared on the left hand side. And also I will subtract 8. Okay, and on the right hand side I have f of x minus x cubed minus 9x squared minus 8 plus f of y minus y cubed minus 9y squared minus 8. Let's verify, is everything all right? Yes, if I add back these terms, I will have this and that. And if I add 8, then I have 8 minus 8 minus 8. It's minus 8. All right. And now I will do a substitution. So now let, for example, g of t be equal f of t minus t cubed minus 9t squared minus 8 for all real numbers t. After this substitution, our equation becomes much simpler. It's just g of x plus y equals g of x plus g of y. It's Cauchy functional equation. So g satisfies Cauchy functional equation also not for real numbers but for rational numbers. Sorry, because we are dealing with rational numbers, so maybe let's write it that our function going from the set of rational numbers into the set of real numbers satisfies Cauchy functional equation. So g must be linear, i.e. g of x equals ax for some constant a. And now, after doing that, let's go back to our original function f, because g of x is that. So f of x equals x cubed plus 9x squared plus ax minus 8 for all rational numbers x. But now we have one unknown parameter. We don't know a yet. How can we know what a is? Well, we can use our initial condition that f of minus 8 equals 0. So let's set x to be equal minus 8. Then we have the following. 0 equals minus 8 cubed plus 9 times minus 8 squared plus 8 times minus 8 minus 8. And after solving it, maybe let's solve it. So here we have minus 8 times 8 squared. Here we have plus 9 times 8 squared minus 8 times a minus 8 minus 8 times 8 squared plus 9 times 8 squared. It's just 8 squared. 8 squared minus 8 equals 8 times a. We can divide by 8. So we have a equals 8 minus 1. Is it right? Is it right? Sorry, I made a small typo. Because we have to add 8. So here we have plus 8. Sorry about that. Plus, 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 plus. So a equals 9. A equals 9. So our function equals x cubed plus 9x squared plus 9x plus 8. And if you wish to write it in different way, I leave the details to you, but it can be also written as x plus 8, x squared plus x plus 1. And it's the only function which satisfies our equation. So the only solution to our equation, f of x equals x plus 8, x squared plus x plus 1 for all rational numbers x. And that closes our problem. So yes, pretty nice problem. Thank you very much for watching, and I will see you next time. Goodbye.